So there's two types of consecutive integer problems, as I'm sure most of you guys are aware. So it might involve just plain old consecutive integers like this one does. So we're going to start with that. It's asking for plain consecutive integers. It doesn't say consecutive odd. It doesn't say consecutive even. Remember, consecutive means like 100, 101, 102, for example. Numbers that are just one right after the other, and those always increase by 1, because obviously 101 is bigger than 100, 102 is 1 bigger than that. So these are always increasing by 1. That's what the consecutive integer is. And so to set up the equation, first of all, you've got two numbers here, right? Because it says two consecutive integers. X is always your smallest number. Since we only have two, I'm going to call it small, and I'm going to call the other one big because we've only got two numbers. So the smaller number is going to be X. The bigger number is going to be 1 bigger than that because it says consecutive integers. So the first number we're looking for is going to be X, and the second number we're looking for is going to be X plus 1. This number's sum implies that we are adding, of course, and then it needs to add up to 35. So we are going to take the first of the two integers, X, we're going to add it to the second integer, which will be X plus 1, and those need to sum up to 35. So for part B, and this is really super important for your quiz, you are definitely going to have to explain why you did something for a consecutive integer problem. That being said, even though I gave you a bunch of space, I'm not asking you to write me, an encyclopedia, a huge big book, a very brief explanation. As long as I can tell what you're talking about, then that is fine. And so add a voice memo to explain how you set up your equation. So these would be some important pieces of information that probably you want to include. So for one thing, the word sum means that you're going to add. So that's where the addition came from. And 2, consecutive integers increase by 1 every time. So that really isn't a lot that I'm asking you to explain. I need to know, where did the adding come from? So obviously that's where the addition came from. And I will need to know why you did X and X plus 1 instead of X plus 2 or X plus 3, something like that. So consecutive integers increase by 1 every time, and sum means to add. So as long as I have those two key pieces of information, that's going to help me to figure out that you know what you're talking about, and that's why you set it up correctly. So now we're going to solve the equation. I'm going to recopy it down here. So we have like terms that we can combine on the left-hand side because we have an X and an X, which is going to be 2X plus 1 is equal to 35. And we need to isolate that variable, so we're going to subtract 1 from both sides. That leaves me with 2X is equal to 34. And then I'm going to divide both sides by 2. So X, my smaller number, is going to be 17, and because we're looking for two consecutive integers, that means the other number would be 1 bigger, which is the large. It doesn't hurt to go back and add those two numbers together just to double check and make sure they actually add up to 35 like they're supposed to, and they do, but that's definitely like a good step you might want to throw in there. Strongly recommend it. Go back and add them together just to make sure you've got the right ones. So the two integers we were looking for in number 1 are 17 and 18. So I'm going to pause here for a second, Question time. Anybody that's unclear about where any of this came from? I'm looking on Remind too. You don't necessarily have to put it in the chat. Alrighty, well, I'm not seeing anything, so I'm going to assume that means we're good. All right, for number 2, and remember I am recording this, so you can go back and look at it too. So 3 consecutive even integers. So this time it's a little bit different. It's still going to have more or less the same setup. I'm going to go ahead and write down here, explain where it came from. I'm going to go ahead and write again that the sum, the word sum means add. And let's see if I'm going to use the same representations of the numbers for this problem. We're not, because this time it says 3 consecutive even. So remember, an example of consecutive even would be something like 8, 10, 12. The list could go on and on and on. Those are not increasing by 1 every time. Those are increasing by 2 every time. So we're looking for 3 numbers. So that means x is going to be our small. The next bigger one will be 2 bigger. So x plus 2, I'm going to call this medium. And our third is going to be 2 bigger than that. So x plus 4 is our large. So those are the 3 numbers that we're looking for. So the equation that we're going, so for explain how I set up my equation, I'm going to say consecutive, even integers increase by 2 every time. That is enough of an explanation for me. So we're going to set up the equation x plus 2 plus x plus 4, and all of that is going to equal the sum of 72. So how do we set it up? We've already covered that. Solve your equation and identify the 3 integers. I'm going to go ahead and combine my like terms when I recopy it. So because I had 3 x's, that will simplify to 3x. Because I had a 2 and a 4, 2 plus 4 gives me 6. All adds up to 72. I'm going to cancel out the plus 6 with a minus 6 on both sides. That's going to leave me with a 66. Divide both sides by 3. My smallest number that I'm looking for is 22. So if they're increasing by 2 because they're consecutive integers, or I'm sorry, consecutive even, that means my small is 22. My medium is 24. And my large number is going to be 26. It definitely helps to go back and double check and make sure they add up to what you need them to. First of all, it's a good sign that they turned out to be even, and we were looking for even integers. So we'll add them together real quick, make sure they actually total up to 72. They do. So I'm pretty sure that those are the 3 numbers that I need. I'm going to pause for just a second. Oh, and the text I just got, notice I did divide both sides by 2 up here in the top one. It's just that I ran out of room, so I like put it over there to the side. But I actually still divided by 2 also. It was just like I didn't give myself enough room right there. So that's why it looks like I divided down here, because I did, but I actually divided up there too. So let me know if that answers your question, dear. I get why that was a little bit confusing. I should have given myself more space. Okay, so if you understand those 2 problems, you understand how, like, they're going to be just like this. All right? Questions, comments? Alrighty, let's go ahead and go over to page 2. So for page 2, it says solve each absolute value equation and make sure you show your work. So I'm looking at my absolute value equation, and I notice off the top of my head that the equation is isolated. The absolute value is already isolated. There's nothing on the outside of the absolute value that I need to eliminate. So that means, so I'm going to kind of write my reasoning while I am, like what I would put for this. So the first thing I would say is that and you can use AV to abbreviate for absolute value if you want. Absolute value is isolated. So I can do case 1 and take case 2. So we've got our case 1. Remember, case 1 is that our equation had a positive outcome. Remember that 3x minus 1 could have either been a -5 or a +5 because the absolute value comes out to be positive no matter what. So we have to solve it for both possibilities. Either that 3x minus 1 was equal to 5, or that 3x minus 1 was equal to -5. Remember, the 3x minus 1 gets out of jail. The bars are gone. Hopefully, they get the support they need. They have a supportive family. Nobody discriminates against them. All of that stuff, and things turn out positively. Or, unfortunately, what happens more often than not is that they get out. People discriminate against them. They don't get the help they need. Therefore, they have a negative outcome. So we've got to prepare for both of those possibilities. So for step 2, you could just say something like 3x minus 1 could be positive or -5. So have to solve both ways. If you give me that, I understand what you mean. So I'm good with that. So now we just need to solve each of those cases for those individual solutions. So we've got +1, +1. 3x is equal to 6. Divide both sides by 3. X is equal to 2. Add 1, add 1. We've got 3x is equal to -4. Don't freak out that this isn't going to turn out to be a whole number. Remember, just leave it as a fraction. 4/3 will not turn out to be a whole number, and that's fine. Happens on these all the time. Just get in the habit of leaving it as a fraction. Next week, we're going to get to start slope. Woohoo! And we like fractions. You don't need to go any further than explaining 1 and 2, because once you get to here, you're really just explaining how to solve a 2-step equation. And at this point, I don't feel the need for you guys to have to explain to me how to do that, because that's really, a below grade level topic. So as long as you explain to me just why you were able to do your case 1 and your case 2, and explain to me why you set up a case 1 and a case 2, you've done all the explaining that you need to do. Remember, whenever we have a math problem that has more than one solution, that you need to put those 2 solutions in the little brackety things that I can't draw, the little curly Q braces. Ugh, that was ugly. This is why I always type it out, folks. And put the smaller one in first and the larger solution second. Even though the order technically doesn't matter, it's kind of good just to get in that habit of doing it that way. So this will be our final solution, -4/3 and 2. I'm going to pause for a second, make sure we're good. Alrighty, for number 4 was a bit of a trick. But hopefully now that I've tricked you, you will not forget this trick over the weekend. So notice that the absolute value is isolated. There's nothing that I need to, eliminate. But something's weird about this one, because the equation is set up so that it says the absolute value of 1/3 y plus 8 is equal to a negative 10. Can you have absolute value, that is a negative? Absolute value is always positive. So there's something jacked up about this particular one. Okay, Lainey, I would just try closing it out and then reloading, and it should work. Sometimes it takes a minute once your Wi-Fi turns off and then turns back on. And you can always copy down what I'm doing on paper for right now too. But it should work. Just give it a minute, ma'am. Alrighty, so we've got our 1/3 y plus 8 is equal to negative 10. You can't take the absolute value of something and have it turn out to be a negative 10. Okay, so absolute value is isolated and equal to a negative number this is impossible. Absolute value is always negative, so there is no solution. So that absolute value is set equal to a negative number. So that means, now sometimes you might have a negative number to divide off the outside, and then that'll take care of the negative number. But if your absolute value is isolated and it's set equal to a negative number, that means that there is no solution. And the reason for that, again, is because it's impossible to take absolute value and have it set equal to a negative. That's literally the definition of absolute value, is that it's positive distance. So any questions about number 4? Alrighty, number 5. So this time the absolute value is not isolated, right? So step 1, absolute value is not isolated. So I'm going to have to get rid of that 2 and that 8 before I can do my case 1 and my case 2. So remember that the 2 sitting next to this means multiplication. That means a minus 8, of course. I feel like it's going to be a little easier. It really doesn't matter which way you do it. Go ahead and get rid of the minus 8 first. I feel like looking at the class kicks I've seen so far, that's what most of you guys did. So I'll do it the way you did it, or at least that most of you did it. So we're going to add 8 to both sides. So we're just going to rewrite everything here. This is equal to 18. Then we need to divide both sides by 2. So now we have our equation. The absolute value of 1/2 minus 9 equals 9. So now AV is isolated. So do case 1 and 2. Why are we doing a case 1 and a case 2? Because 1/2 x minus 1 could be positive 9 or a negative 9. So we're going to have to solve it for both potential outcomes. So I'm going to write my case 1 here. So they're out of jail. 1/2 x minus 1 is equal to positive 9. We're going to hope for a positive outcome. Case 2, they're out of jail. but sadly they have a negative outcome. In both cases, we need to add 1 to both sides. So 1/2 x is equal to 10. We're going to cancel out that 1/2 because remember what you're technically doing is dividing by 2. So what is the inverse of dividing by 2? The inverse of dividing by 2 is multiplying by 2. So I'm going to multiply both sides by 2 so that I've got x is equal to 20 for one potential solution. I'm going to do the same thing over here. 1/2 x is equal to 10. Oh, that should be, nope, my bad. That should be a -9. My fault, guys. I didn't set up my case 2 right. That should have been a -9. I didn't put that in there. Okay, so I'm going to multiply both sides by 2. So my other potential solution is x is equal to -16. Again, you don't have to go through and explain to me how you solved that equation. Those are pretty basic 2-step equations for a class at this level. So I'm okay with that. I'm more interested in, did you know how to approach the absolute value equation? And remember, for your final answer, get your, if you're like me, ugly brackets and put them right there inside of the ugly brackets in order from least to greatest. Oh, can everybody else hear me? Is it just Milton? Sorry, I was working that. Can everybody else can hear me okay, right?
Yeah.
Okay, I thought so. Milton, try hanging up and then rejoin the call. That'll usually fix that. Or, I know this sounds stupid, but double check and just make sure that maybe your sound is on. I did that the other day where I was like, my speakers are messed up and I just had my sound off. So try that, since everybody else can hear me. Okay, questions, comments, concerns about this one? Okay, not seeing anything. All right, for number 6, I have an equation that has numbers in the denominator. I'm going to rewrite this because I don't like how it's kind of smushed up here with the problem number. Makes it hard for me to show my steps. So you are more than welcome to do it a different way besides the way that I do it. But personally, I'm going to do that whole ditching that denominator, right? Yeah, you can totally just do it on paper and then, yeah, absolutely, ma'am. Totally fine. All right, so but we need to get to the bottom of what's up with that later. I'm going to have you hang back for, well, shoot, I can't right now. We'll figure it out. Okay, so you notice that you've got you're dividing by 7, right? That's what it means to divide by 7. So we're trying to get the variable by itself. So we need to get rid of that 7, don't we? So we need to cancel out dividing by 7, and we need to do that by multiplying. And we've got to multiply both sides by 7. So the first thing I needed to do was cancel. I was dividing by 7, and we canceled it out with multiplication by 7. So that 7 is in the denominator. It needs to get out of there so that we can solve for b. So I'm going to multiply both sides by 7. That will leave me with just a b plus 2 on one side. And then remember, when you're multiplying by fractions, you're just going to multiply those two together right there. So that's going to be equal to 21 over 5. We still need to fully isolate that b, and we are going to need to do that by cancel plus 2 with a minus 2. So we're going to subtract 2 from both sides. That's going to cancel, leave me with a b. And you guys are allowed to use calculators. So just in case, let me show you where I put a pretty solid calculator for you guys. Because I know we have all kinds of issues with like, does it do fractions? Does it not do fractions? So I'm going to remind you, I gave this to you, and you are allowed to use it on the quiz if you like. So under helpful tools. Oh, you know what? I forgot. You guys, I got you guys late so that I never gave that to you. Okay, I'll add this link when we get out of here so that it'll say scientific calculator. It'll say it at the top. So it makes it pretty easy for you to do fractions. So we need to do the problem 21 over 5 minus 2. So I can put in, this actually does fractions. See how there's a fraction button right over here on the right hand side? So you can do 21, click in the cursor and do over 5. Move the cursor out from the outside, minus 2, and it gives you your answer right there. But if you want it to be a fraction, which is pretty cool, all you got to do is click that, which I want it to be a fraction. So if you want to convert it to a fraction, you just click that button. So it gives it to you as 11 over 5. So I'm going to put the link to that calculator on your Google Classroom so that just in case you have to deal with fractions and you don't have a calculator that'll do that for you, this one does a really good job with that. So again, just to make sure we're all on the same page, I'm going to clear this out. The way I did that, I hit the fraction button right there on the right hand side, 21 over 5. I scooted my cursor out, minus 2. It starts off with a decimal over here to the side, but you can just click convert to fraction and it gives it to you just like that. So our solution is B equals 11 over 25. Questions about number 6? Alrighty, so number 7, once again, we've got denominators that we really need to eliminate. So, and again, I'm going to write this down here at the bottom. I hate how that's smushed. So the first thing I noticed, just because it happens to be over here on the left, is that I want to cancel out dividing by 4. And so the opposite of dividing by 4 is multiplying by 4. But I also have a 6 that I need to cancel out as well. So that is where we are going to use that, ditch that denominator, when we've got 2 denominators this time that we need to get rid of. In the last one, we only had to get rid of 1 denominator because there was only 1 variable. But now we've got 2 variables, and they're both on top of a denominator. So that's where we got to do that, ditch that denominator, unless you just really enjoy working with fractions, and then that's okay too. So we need to find, so first of all, we have to cancel dividing by 4 and 6. And the way we're going to do that is by multiplying, because that multiplying will cancel out those denominators, and we're going to multiply by the least common denominator. Remember that ditch that denominator method. So the smallest number that both of these guys will go into is 12. 4 and 6 will both go into 12. So we're going to multiply both sides by 12. So I'm going to pause for just a second. Remember, that's that ditch that denominator. So 12 will cancel out 4 and 6. Let's see how that works. So on the first side, when you do multiply, you got to make sure you multiply it by both. So that'll be 12m plus 24, and that's all over 4, right? So here's where the magic happens, because now you can divide 12m by 4. That turns out to just be a 3m. And then 24 divided by 4 is plus 6. We need to do the same thing over to the other side so that we've got 12 needs to be multiplied by 3m. So that would give us 36m, and then 12 times 1 gives us 12, and that's all over 6. 36 divided by 6 gives us 6m, and then 12 divided by 6 gives us 2. So now we've got just a basic equation with variables on both sides. We've ditched all those denominators. We canceled out all the fractions, so now we have an easier problem to work with. So now I'm going to move the variable to one side. So I'm going to cancel the 3m. So cancel 3m with a minus 3m, because that's the opposite. I'm going to subtract 3m from both sides. We know that leaves us with 6 is equal to 3m plus 2. From here, you don't need to write out your steps, because I know at this point that you know what to do, because this is just a basic 2-step. I was more worried about the first part, you explaining. So we've got 4 equals 3m. Divide both sides by 3. Don't freak out that it doesn't turn out to be a whole number. That happens all the time. We're just going to leave it as the fraction 4 over 3. Kind of thought there may be some questions about this one, because it's been a little bit since we've done that. Ditch that denominator. Crickets. All right, I'm going to assume we're good. All right, flipping to the last page. Those literal equations. Yay, that everybody's favorite. All right, so if you can do these two, you will be just fine on the quiz, okay? So for number 1, I'm going to rewrite it down here so it's left smushed. So we know that we're trying to isolate the x, because the problem tells us that we're solving for x. So off the top of the bat, I notice, here's the x, that plus 4y is sitting on the same side and needs to go. So I'm going to cancel a plus 4y with a negative 4y. I'm not going to say subtract 4y from both sides. I can see that's what you guys did. That part's obvious. I want to know, why'd you do it? You did it to cancel that 4y. So the 4y is now going to be gone on the left-hand side. I'm simply left with mx. Because 3t and minus 4y are not like terms, I'm just going to rewrite them as a 3t minus 4y. I'm just going to write them in 2 separate pieces. And last but not least, I know that the m sitting next to the x implies multiplication. So I am going to cancel multiplication with division. So I'm going to divide this side by m so that I can get the x by itself, which means I'm going to have to do it over on this side too. That's going to leave me with x equals 3t minus 4y all over m. X is isolated, so we know we're done. Questions, questions, questions. Alrighty, last one, grand finale. So I'm going to rewrite this again down here. All right, so we know that we are trying to isolate a. We're trying to get a by itself. So off the top of my head, I noticed this minus q. So I'm going to start there. I'm going to cancel a minus q, and I'm going to do that with a plus q. I'm going to add it to both sides. So that'll leave me with 3/4 a is equal to k plus g. Don't just write kg because we didn't multiply those. We're adding them together, but we can't combine them since they're not the same variable. And now I see another one of those pesky denominators I want to get rid of because this means I'm dividing by 4. So I'm going to cancel division. That's a W, means with multiplication. So I'm going to multiply both sides by 4 to cancel that out. The 4's are going to cancel over here, which just leaves me with the 3 and the A. And over here you have a couple of different options for how you want to write this. I'll count either one of them correct. You could have multiplied the 4 by each of these, and you could have said 4k plus 4g, or you could have put the 4 in parentheses and just did it like that. Either way, it means exactly the same thing. I don't care which way you did it. Either one is fine. And my last step is to get the A all by itself for real this time. So we need to, and the 3 sitting next to the A means multiplication. So we are going to cancel multiplication. And we're going to do that with division. So I'm going to divide both sides by 3 so that A is equal to 4k plus 4g all over 3. So I'm going to pause here for a second. If you can do those, you'll be good on the real thing. All right, so I'm going to shut up now. I will take, so I'm still going to stay on the line. I've still got another, I can make it to, since I don't really have to go anywhere, I can still hang out for another, 10 minutes before I need to make it to my other meeting. So at this point, what you guys should be doing is either, I need your study guide with a typed out explanation. I mean, obviously the smart thing to do would be to, have been doing this along with me. Either add a voice memo or give me an explanation. Once I see that